Hi guys, this is a video demonstration of the Test Electronics 8-inch RAN style Fixtureduino. This is an Arduino microcontroller based system development kit. It allows you to build your own microcontrolled test fixture. Now we have a variety of sizes here. We have a 6-inch version. This is the 8-inch version. We also have a 10-inch version, 12, 14, 16, and 18. So a wide variety of sizes here. Now, what the package comes with is the hardware for the press-down rods and some double-sided tape. But the thing I really want you to know about, really show you here, is this scrap piece of FR4 material that's the same as this press plate here. We want you to practice drilling your test pins in this material so you get it all perfected before you drill in this plate. That's what that's for. So let's power up a test. So the way that, what we got is a little transformer, and it's plugged into the back here. This is the Arduino Uno. The power goes in right there. So let me just plug it in, and it'll power up. And we can run a sample test. There you go. So to run a test, we have a little demonstration circuit board built in that it runs a test on, so you can use our software as a framework for integrating all these devices, the front panel, the LED, the LCD, the remote control, which I'll show you in a bit. It integrates them all together into a test system that you can use and build yourself. Now this is discharging a capacitor. When it gets below 2 volts, it's going to go through and it'll press any key to test or recognize my voice to continue with the test. Press any key to continue or recognize my voice. So let me disconnect power. So you do that first thing when you get it. Make sure the test works. And I'm going to show you what comes inside this fixture. Just remove these 4 feet from and the bottom will come right off. And inside the fixture, you're going to have some bubble wrap. Now don't throw this away, because inside this bubble wrap is a remote control, which you will need. Now this remote control duplicates these panel buttons here, up here, and it also has numeric buttons. So in case you have a lot of tests, say you have 80 tests, instead of scrolling all the way up to 80, you can just press 80 on the remote control and it'll go right there. The next thing that's in here are a few extra wires. You can use these wires to go from your proto board to the Arduino shield, or from the Arduino shield to the test pins, or whatever you want to use these wires for, they're available for you. Another thing in here is a schematic of the test circuit. Very simple circuit, 5 volts, a relay voltage divider, another relay voltage divider with a capacitor across it. The idea is to measure 0 volts, 2.5 volts, and then have a capacitor that delays it so we can test how it'll fail. This capacitor is going to cause this to fail because it takes a while to charge, and we'll show you, we will demonstrate to you how to handle that. And then this here is a printout of the first test run. It shows you all the voltage measurements that this tester made as it ran through all the tests. So that's the schematic. The next thing to show you inside this fixture is this little test pin. This is a simple bed of nails test pin. Same thing as you will probe your circuit boards with. You got your spring pin, you got your socket. You just put them together, press the spring pin in here, and put this spring pin onto this connector. And what this is this is going to be used, you need to probe a ground point with this. Now this isn't your primary ground point. You're going to have a primary ground point in your circuit board. You probably find another place where you can probe ground. And when this hits ground, 200 microseconds later, or whatever you set this to, its default is 200 microseconds, it will start the test. 200 microseconds is to stop for switch bounce and to allow the board to be pressed all the way down. Another thing you want to do is set this a little bit lower than the other test pins so that this is the last pin that contacts the board, because your test is going to start when this board is connected. So let me connect power to you and just demonstrate that real quick. Okay, so touch this to ground and the test starts. It's that simple. That's what this is for. So we'll put this away for now. And let's turn this thing right side up. And I'll run through some tests here. And let's just reset this and start again. So let me describe this to you. The tests, we'll first measure the voltage divider, 0 volts, and then we'll measure the high voltage, which is all documented here. Then we'll go and pass the low charge of the capacitor, let the capacitor charge up, test the high charge. Then now it's charged up, it's going to be discharging. When it gets below 2, it's going to continue on. And then we're going to go into the reading a resistor. This is some demonstration test. And that concludes the sample test. Now if I test again right away, it's going to fail because this capacitor is now still got a charge on it, and this demonstrates a failure. Okay? Now what we can do is go over the buttons on the front panel. This is the test button, which we've been using. You're familiar with it. This is the smart test button, which is a failed retest. So what it does is when you do a test like we did now and one of them fails, it logs it to this button. Now this button knows this test failed. So if I press it again, it will start from this test and continue on. So if you have something that failed and it just needs a potentiometer adjustment, your technician can adjust it, press that button, it'll continue on with the test. This scrolls up and down the various tests, and if you go positive up into the test, you can start a test by pressing the start button, or you can go down into the configurations and change things like the test delay. We can set that to 100 milliseconds delay instead of 500. And we can scroll down and set the LED intensity up a little brighter if you want a brighter LED. Scroll down a little more, turn your voice control on and off. Scroll down more, you got your Bluetooth. This has Bluetooth output. You can print out it allows you to print out the tolerances, the amount of tests, or just the test measurements. What we do is, when we test at 100 times, and we tell it how many times we want it to pass out of those 100 times. So in this demonstration, we told it we wanted it to pass 80 times out of 100. So 80%. If 80% or more of the tests pass, it passed. So for example, most of these passed 80 times and were only test checked 80 times because they passed 80 times. This one here passed 80 times but was checked 84 times. That's the voltage divider. What probably happened is a little bit of switch bounce on the relay when the voltage divider first kicked in. So that's basically how the test runs, the demonstration. Now when I press this again, this capacitor should be discharged, and it continues with that step and goes on through the testing. Now you'll notice that it's testing a bit faster now because I took out the 500 millisecond delay and changed it to 100 milliseconds. So it's going through it's whipping through the test pretty fast. And you can press any key like I did there, or say test to continue. So now what I'll do is I'll put it back. I'm going to go actually to let me reset this, and we will go to show you how to save this. First, what we'll do is I'm going to show you AQL, -2, full functional, or partial test. So we'll select partial test. Now it'll do everything tested partially. So let me demonstrate that. We're going to, what that is, acceptable quality level, is we're going to say these resistors are okay, the capacitor is the thing that might be bad. It could be put in backwards or old and corroded. So we're going to skip the resistors and just check the capacitor, and that's what this did, and that's why it happened so fast. Now if we wanted to save that when power went out, we can. We just scroll down to Save Preferences, press Save, enter the password, which is up, down, over. Saved. Now when I restart this, it will start with only partial AQL test instead of full test. And you might want to do that because most of your tests are going to be AQL level testing. You might want to test one full test out of 100 AQL tests, or one full test 99 at AQL, acceptable quality level. Okay, so what I'm going to do now is just another thing we got here is restore factory defaults. Press that, and then it's restored, and then we'll go back up and save these preferences just so it's back to the way it was. Save preferences, enter password, and now that's saved. So that's how to use the setup routine, and to scroll up through tests, you just can select any test you want, either with the scroll up or with the button. Let's just press 9. So I'm going to press 09 and change sign because I was in the negative, so it went off on negative. And we can test that. I could press that test button or this test button. And it passed, 09. Okay, the next thing we've got from test 90 to test 99 are special debug tests. We put 5 of them in for you, and you have 5 left to customize by yourself. So let's go to test 90. Test 90 is power on, and we'll scroll up. Test 91, keypad values. Test 92, remote values, microphone, and then these are all empty. Test 99, conveniently, we put a power off there. So you could use the 90 and 99 for power on, power off when you're doing debug. Now let's go to 92, or 91 actually. And this is keypad values, and we'll test that. And what it is it's 124, we got 119, 120 here. But it gives you, the analog input is 124 to 0. So the test button is at 133, and it just tells you what value each one of these buttons returns, so when you're programming it. Now the nice thing about this is you could add a button here. This is just a resistive strip, so you could add a button anywhere you wanted to for a custom button. All you'd have to do is put a piece of sticky tape on there, program the value you get from this on there, and you're done. You added your own custom button to this unit. It times out and is able to continue to other tests in about a minute. Remote values does a very similar thing. You don't have to use this remote control, you could get another one. And, oops, I went out of remote values. Let me put it back on 93, or whoops, that was 92. Remote values. Now, press test and press a key on the remote. And as you can see, it changes the number. And so what you could have is a different remote than this, and you just program this number into your test routine, and it'll pick up whatever button you want to pick up from the remote. Now, that goes through all the settings, options, and debug testing. Now the next thing I want to do is show you the options available for this. Now this is the basic bare bones microcontrolled development system with the Arduino Uno installed. The first thing we could do is, instead of having this plate and having to drill it, line up your circuit board, you could have this plate instead, where these are adjustable side to side like this, you can adjust these up. You can loosen these screws and adjust these up and down too. So you can basically position this anywhere you want and tighten it down to wherever you need. You loosen both of those. So you can position this anywhere you want, position these anywhere you want, and set up for practically anything you need without having to go through and machine a press plate. So that's the advantage of using an adjustable press plate. The next option we have available is adding Bluetooth to this unit, which is very simple to do. In here is a socket for a Bluetooth, and you just add one of these Bluetooth units to it by pressing it in here. Now let me turn power off. And we'll install Bluetooth. Turn power back on, and the Bluetooth unit should light up and flashes a little green there. Now, turn it back over. We can control this with Bluetooth. Now there's with the Android test pads, there's a big one. There's all kinds. There's a small one. These are both Archos. This is a 10-inch. This is a 7-inch. And they even have a 4-inch, which is kind of the size of my cell phone. But their 4-inch doesn't have a capacitive touch. It's a resistive screen. So the bigger ones are a lot better. I like the capacitive screens. It's easier to touch the buttons. Okay, so we'll turn this on, and I'll demonstrate Bluetooth, the ability to print out Bluetooth with it, and the ability to control this remotely with Bluetooth using our Android applications. And this Bluetooth can also be linked to a computer, so you can save the measurements on your hard disk instead of just printing them out. Whatever goes through across serial and can communicate with Bluetooth will be able to save your test values. So as this boots up here, we'll show you. Now I already paired the Bluetooth. Okay, so I'm going to go to the print simulator first. And I'm going to select Linvor. That's the manufacturer of that board. Linvor. And I'm going to select Connect. So it's connected now to Bluetooth. And what I do now is just press Test. Did I change this value or something? Let me reset this. Oh, now I disconnected Bluetooth. Let me shut this down. And when you disconnect Bluetooth, you got to restart it. Okay, connect. Now it's connected. Now all I got to do is press Test. Okay. I had the settings to Bluetooth off or something there. So we're getting this printout here on your Android tablet via Bluetooth. So that's one of the things you can do with Bluetooth, is send it to your Android tablet. And right now it's counting down, it's discharging that capacitor. This could be, that discharge could be adjusting a potentiometer or anything like that. That's what we're trying to simulate here and show you how to do. Now the next thing we can do is I can change this over. We can exit out of this application and we can control it remotely. Now I have to change over the Bluetooth to instead of displaying tolerance, we're going to display remote. And I will pull up a different application that has a remote control on it. Now this is the display, the LCD display, and then here's all the buttons. So let's connect. I think I pressed connect twice. You got to be careful. Touch and read these. Okay, good, connected. Okay, so press the test button. And what you see here is what's on the LCD display. And this across here are all the test buttons there. And you could use this inside to remote control this in a temperature chamber, but don't go too high and too low on temperatures. There's only an Arduino in this. Or wherever you need a remote control, you've got it here with Bluetooth. Okay, so that describes Bluetooth. I'll shut that down. And the next option available would be to upgrade from the Uno to, say, a Mega. So the way to do that is basically, it's very simple. You just unscrew this screw, unscrew another mounting screw there, and you put a Mega in there. It just slides in the exact same place this comes out of. It screws right in, bolts right in. You have an option for a few basic things with this Mega to plug in. We normally use this expansion board, and that plugs in like that. The expansion board gives you all your digital outputs, your analog outputs, and expands it out to the Bluetooth B here, and you got a COM1, COM2, COM3, and your I2C. Now the thing about this is we will connect Bluetooth to, say, COM1 and a printer to COM2 and a barcode scanner to COM3, and leave COM0 empty because that's our programming. With this, you have to remove the Bluetooth B each time you're programming it. Each time you program it. So that's that option. The other option is, here's all your options for the Mega. Your expansion board, sensor board, which has all the features of this except for the little breakouts, but you can still access all the breakouts. It's just you can't use a standard cable. You have to just plug into each individual pin. And then this one is a breadboarding type thing. It's handy for soldering your own circuit there, or breadboarding your circuit. So whichever method you want, you could use any one of these expansion boards. Now another thing we can plug into there is the Arduino Nano. This is the Arduino Nano. It's a very small board. And the advantage of this board is that it has 2 more analog, and it's very small. Now the disadvantage is it's powered by USB, so it doesn't have much power unless you use this module, this shield, which plugs in like that.